Hello friends, this is Altbeer, and I am here to walk you through building the Godzilla vs. Blade Runner badge. So for those of you that got kits and haven't built it yet, you can use this as a resource to build your badge. So what we have laid out here is the components that we're going to be working with. We have the actual badge PCB. We have the Adafruit Trinket M0, which is the IC that we're using on the board. Then we have 10 neopixels, 8 of which are 5 millimeters in size and 2 of which are 8 millimeter in size. And neopixel is a type of LED that is programmable. And then we have 5 capacitors. These are 100 UF capacitors. I think these are 25 volt, but you can use either 16 or 25 and it works fine. And then we have resistors, a total of 8 resistors, 7 of which are at 470 ohm. 1 is at 100 ohm, and basically that resistor handles the current load of the bigger LEDs. We have a big battery pack, the lanyard, and some Velcro to put the battery on there. So that's the basic kit. So we'll get started by clearing off our workspace, and then we will start with the resistors. I always like to start with the resistors because they're the easiest to deal with. Okay, so the resistors on the board are going to go into various slots, and on the back of the board we have the listing of where all the components go. Kind of bring it down so you can see better. So basically for every component I listed out what it was, and all these resistors are these little rectangles. And we can, by looking at this board, tell that the 100 ohm resistor goes on this place. So we're going to place him first. And so basically we take the paper off and we fold the resistor over, and then we're going to put it in on the front of the board. And that is in the right location. All right, now we're going to do that for the other 7 resistors that are 470 ohm. One of the unique things about this board from my other designs is that I put in a capacitive touch area to be able to use that instead of a button for changing the LED modes. So we'll see how that works in just a little bit. When we get to working on the trinket, I will show how to put the code on the trinket and how to program it, and what my program that comes with it does. The trinket is programmed with CircuitPython, so the code is Python code. You'll notice I'm putting in all of the connections first to get all these resistor components on the board, and then I will start soldering them. Now while I've been doing this, the soldering iron has been heating up, so it should be ready to go when we are. And there we go. Now you'll also notice I folded these over to prevent them from falling out as I flip the board over. So the solder I'm going to use is a 60-40 mix. It's a leaded solder, so I believe the 40% is lead. It's an 0.8 millimeter thickness, and it's a rosin core solder, so it has rosin in the center of the solder. That means you don't have to use flux or anything like that to maintain steady temperature when melting. All right, and I'm going to take my glasses off because I'm an old man and I need to see. Now when you're soldering, you want to put the tip of the iron, or just above the tip of the iron, on both the solder pad and on the pin. That way it heats both up for a good seal. Because if you only get one or the other, it will have a solder joint that might break away. And we want our solder to look like little volcanoes, so that kind of that angled up look instead of a big ball. You don't want big balls of solder on the solder joints. And you also want to make sure that when you're done soldering the joint, that the solder on there looks nice and shiny. If it has a tarnished look, it means it's not got a good connection. It didn't have a good bond. Okay. And with that done, we will take a look, and all of our solder joints look good. So now we're going to take our diagonal cutters, which have diagonal edged blades, which make it perfect for snipping off these wires, and we're going to take all the little legs off those resistors. Just snip them off of there. You don't want to snip so close to the board that you damage the solder joint, but you want it close enough that you're not going to have these wires sticking out and stabbing you when you're wearing this as a badge. Okay, so now we're ready for our next component. And the next component that I like to put in is the big LEDs. And so these NeoPixel LEDs, you'll notice, have different height legs. So all of the legs have different heights, and that corresponds with where the flat side of the LED is. So you'll notice that in this case, there's a flat side here and there's a flat side there, and you can see how they line up. And when we look at the back of the board, you can see where the flat side is supposed to go with the LED on the front. So we're going to line it up like that and put it in. Like so. And then we'll just kind of bend these out a little bit to make sure that that LED doesn't fall out, because it is a little loose. And then we'll do the same thing here. So this one, we want the flat side going this direction. And so we look at where the flat side is right here, and we will make sure it's going that direction. Sometimes you have to pull these pins apart a little bit from the way they come from the manufacturer. And then trying to squeeze them into the right holes is always fun. But you'll get that with most through-hole components. Alright, once again, just bend those out a little bit. And we'll go ahead and solder those. Now, unlike the resistors, I'm not putting everything in at once here because these LEDs, the solder pads are very close together, and it would be hard to work around all the pins of all the other devices if I put the components all in at once. So I'm going to do these, and then I'll snip the legs off, and then we'll do the next set. So once again, we want to hit both the pad and the leg of the LED. And with the pads so close together, you want to make sure that you don't put too much solder on there, because it could cause a bridge where it connects two of those legs together. Okay, so those are done. We're going to take our trusty cutters and cut these legs off. Okay, now we'll do the next group. And these are the smaller LEDs, and they're similar in that some of the pins are higher, and the higher pins correspond with the flat edge. And so when we look on the back, we can see that the flat edge here is going one direction, and the flat edge here is going the other. Same here, so they're popping opposite directions. So that means we'll want to put the one on top going out this direction. And then this one we're going to put going the opposite direction. We can go ahead and get the other two in for this side. And we'll solder all four of these at once. Okay. And now we're ready to solder. Once again, these pads are really close together, so you want to be careful that you don't get solder off of the pad, otherwise it could bridge the connections. And with these NeoPixels, the reason they have four legs, unlike an RGB LED where it might be like common cathode or common anode, these have a positive and a negative pin for power. And then they have a signal in and a signal out pin to where it's chaining digital signals between the LEDs. And what that means is if you screw one up, you can actually prevent the whole chain of them from working. because it's not going to pass on the digital signal that the properly soldered LEDs are looking for. Okay, let's take a look at those. Those are looking pretty good. So now we're going to take our cutters and we will cut these legs off. Okay, so while we're on this side, we do have one more thing to put in here. Now, this is an optional piece, but the trinket gets mounted right here on the board, and I want to be able to remove this trinket to use it on other projects when it's not controlling the board. So I'm going to put in these female headers that the trinket can plug into. Now, one thing you'll notice is they're kind of wobbly, and I want to get them stable, so I'm going to use some male header pins just temporarily on top, just to give it a nice solid base, so it's very perpendicular as I'm soldering the pins. And then when we come down here, we have all the pins lined up to solder, and we're not worried about the angle of the female header pin on the other side of the board. Alright, and with these, the pins are fairly flush to the board, so we don't have to worry about trimming them with the cutter. So we will pop out those temporary headers that we put in, and there's the way that looks. So now we have 4 more LEDs over here that we need to deal with. And because these two are next to each other, I'm going to do 3 and then 1. So when we go to look at how these get mounted, we can look at where the line is. And another thing I should have noted for you is that to make it easier to identify where the longest pin goes, I made the pad on that side rectangular instead of oval. The rest of these are oval, and then we have a rectangle here, here, over here, and here. So it looks like these 3 are all going to go the same direction, and then this one comes backwards. So we'll do these 3 first, going all the same direction. And now we'll solder those up. Alright, so let's take a look at those solder joints. And those look pretty good. Nice little volcanoes. They're nice and shiny. No bridges of the connections. So we're going to use our cutters to cut the legs off. And then we have one LED left. And we can see based on that rectangle where it gets placed and how it gets placed. Let's solder that up. And that one looks good. All right. So now we're going to work on the capacitors. Now, just like the LEDs, the capacitors go a certain way. So the resistors are the only things that can go either way. The LEDs have a certain direction and the capacitors have a certain direction. So you'll notice there's a plus and a minus listed here. And on the capacitor itself, it's going to list which is the minus leg. And the minus leg has the stripe, similar to on the board, the way the filled in color is the negative. So basically what we're going to do is when we put these capacitors in there, we are going to make sure that the long leg goes into the positive hole. And that will mean that the stripe will line up with this darker colored in section of the schematic on the back of the board. And so for these, we can put all 5 in at once and just kind of open up the legs to make sure they don't fall out. Okay, so now we have all of our capacitors ready to go. So we'll get these soldered up. All right. These capacitors, they act kind of like little inline batteries where they will receive charge when they're not needed, but if there's a current draw that's greater than the supply on the particular line that they're serving, they will fill the gap and discharge to take care of that current draw. And that was important in this design for the NeoPixel LEDs because they had a large current draw if many of their individual LEDs were lit. So each one of those NeoPixels has a red, a green, and a blue LED. And when all 3 are lit at the same time to make a bright color, it was actually more current draw than the trinkets pin could handle. And that's why these are bridging the gap. That doesn't happen often. It could do 1 or 2 colors fine. It was only when all three hit that it was too much, and it would cause problems in the circuit, and that's where these became a requirement. And so here we see that all of the components are on the board and everything has been soldered up. Now for the trinket, we have to do a little soldering on that board next, because the trinket, when you get it, it comes like this. And so we have to put his legs on in order for us to be able to plug it onto the other board. Now it has 5 pins on each side, and they give you more than enough here, probably in case you break it in the wrong point, which I've been known to do. But there's a 5 pin, 1, 2, 3, 4, 5, and there's another 5 pin. Now what I've found is the easiest method to deal with these is using one of these tiny breadboards, and we will put the legs in, make sure we get it the right distance so that it can plug in and the leg will go in the right place on the other side. So it looks like that one's going to go in the second row as well. So this holds the legs nice and perpendicular and lets me plug that on there, and I can solder it up just like that. So that's what we're going to do. You do have to be careful when you're doing this method that the board stays pushed down. Otherwise it can lift up on one side as you're doing the other side. So we're making nice little shiny volcanoes. Okay. So that is the end of our soldering, and now we get to play with the code and the board. So I'm going to pop that off of there. Now whenever I plug in a new electronic into my machine, I always try to use one of these. It's a USB digital tester. I'm not testing anything. I'm not trying to determine like what the voltage is or the current draw. I'm just using this as a filter between my PC and the device in case I screwed something up and that particular device has a problem. I don't want it burning out my USB port on my PC. So these are cheap. They're like $5 and they're worth every penny because I have, by not using these, damaged systems. So we're going to plug this into my computer, and then let me load up Explore here so that you can see when I plug this in, it already has CircuitPython installed on it, so it should open up a Windows Explorer drive. So let's take a look at that. Okay, so what we see here is this is the CircuitPython menu. So CircuitPython is already installed on the Trinket, and this is the Trinket that it is that we're viewing. And there's a main PY file, but there's also some library files here, and you have Windows drivers and other things. For my particular code to work, I've noticed that with some of the newer versions of preloaded operating system or firmware that they put on the Trinket, my code has some issues. And rather than try to make it work with every version of CircuitPython out there, I have a specific code base that I referenced it off of. And we will show you where that's at. So basically, I'm using a firmware version of 2.3.1 for the CircuitPython for the Trinket. And what we're going to do is upgrade the firmware or downgrade the firmware on this current board that I'm playing with by just copying the file over to this drive. So you'll see this was mounted as the E drive on my system, and it has a CircuitPy designation. Now what we have to do is put it into firmware update mode, and we're going to do that by pressing the button that is on the Trinket twice, but it's not going to be like a double click like you would do for a mouse. It's more like a click, pause, click. And so when we do that, you'll see it'll mount a different drive on this thing. Click, pause, click. And it closed out my Explorer window, and then it opened it up again, and now you'll see it says Trinket Boot. And now this Trinket Boot is also the E drive here. This is where we want to copy this firmware file. So what I'm going to do is open up my command prompt, just because it's easier to do it from there when showing people things. And I am going to just copy this file name over to the E drive. Now when that happens, it's going to reboot the Trinket. And so the Trinket is now rebooting, and it has a solid light, and when it's done rebooting with the new firmware, it'll open up an Explorer window again. And if you're wondering where this code is, you can get the Adafruit firmware from the Adafruit site, and I'll show you where that's at in a minute. And then I also have a copy of this specific firmware that I use in my GitHub where my code for the badge is. So we can show you where that's at in a minute too. But we'll notice that it popped up, and now it has the Trinket is showing all these same files that it did before, but now it's at the new firmware. And we could confirm that by looking at this boot out file, and it shows you specifically which version it's running. But what we're going to do now is copy the code. So back to my command prompt, I'm going to take a look in the code directory. And we'll see that I have a library file that I need, and I have some other files here, a main and some NeoPixel files, and we want to copy all of this over. But the first thing that I want to do, because overriding directories doesn't always work well on a Trinket, it doesn't clean up, it moves things to a temporary like recycle file, and this thing has very little storage. So what I'm going to do is over here, I'm going to take this lib directory, which is the main directory that has the libraries for Adafruit's code that they put on there by default. I'm going to hold down the Shift key and hit delete. And it's prompting me in a window you can't see, are you sure you want to permanently delete this folder? And I'm going to say yes. And what that does is it bypasses any kind of recycle bin on the drive. That way it frees up all that space. And now I can do an X copy of all of my files over to the Trinket, and there should be room for it to take them all. So let me pull up my X copy command. So with Xcopy, I'm just going to have it do everything in this directory going to the E directory. I want it to show me what it's doing, do recursive subdirectories, and overwrite files. That's what the FSY switches are for that. And we will do that. And we will watch it copy, and it copied all the files. And one thing that is noticeable right away with CircuitPython is you'll notice it's starting to flash the lights using my code. I didn't have to reboot the device. I didn't have to pull it out and plug it back in. It just automatically saw that there was a new main.py file and executed it in place of the current one that it was running, which is kind of a cool feature. It allows you to code in real time for these devices. So speaking of that code, I wanted to take a quick peek at what is actually there. So let us look at my Atom program. So this code is it's Python, and it's not very complex. Basically, we're going to import some libraries, including the touch library for the capacitive touch routines. We're going to import the NeoPixel library for dealing with the NeoPixel signaling. We're going to define some variables as far as like the NeoPixel chains that I have going on. So basically there's 10 LEDs on this badge, and they're broken up into 3 different command chains. So basically we have them defined right here in the code, where I have one chain has 3 LEDs, another chain has 3 LEDs, and then, another chain has 4. And then I use that in the code as I'm calling out what to do with the different pixels and which pixel chain to reference. I define some functions here. The wheel functions are to basically auto wheel through different colors on the NeoPixel. The siren is more of like the red and blue flashing alternating. Then we have flashing red and yellow, or flashing red and white. We have flashing blue and yellow, flashing red and blue, different things that I would need to call. Random colors, using the random functions. And then the main line looks for the mode. So what LED mode is it in? If it's in mode 0, then it runs this routine. Mode 1, the next routine. Mode 2, the next routine. And then the mode is changed by looking for touches on the touch pad. And that's all there is to it. It's not very complex, about 250 lines of code, a lot of which is comments. So it's very easy to write code using Python in CircuitPython. So I just wanted to walk through that because of that. That way people can rewrite the code and make it do other things. And so now what we're going to do is check out if we were successful getting this working on our badge. So we will unplug the trinket, and we're going to bring our badge over, and we will mount the trinket into the badge, and we'll plug it back in to power it off of my computer. And it looks like it's working. So we have Godzilla's blowing fire. We have the sirens, all 6 lights of the sirens are all working. So every NeoPixel is flashing the way it should and doing what it should. Now, the last step is to deal with the battery. And I'm not going to go into a lot of detail here, but this is what the battery looks like. It mounts on the back, and sorry, I had a little technical difficulty there, but where we left off before my video froze was I was mounting the battery. I use Velcro either in strips or in dots like this to just mount the battery onto the back of the unit, and just gets mounted right there. And then you put the wire through the hole and plug it in to power on the badge. The badge itself, like I said earlier, is capacitive touch sensitive, and I have different modes. So we can see how that operates by touching the badge. Live demos. There we go. And so that's the second mode where it's going through different colors. And then this is the mode where it just flashes random all across. And then the last mode is all off. And then we touch it again, it goes back to mode 1. So that was kind of a cool feature, I thought, for a wearable badge to be able to touch and change the LEDs. Before I let you go, I do want to touch base on where you can find all the code that we talked about. So we have, I'll share this. Adafruit, for the trinket, their product number is 3500, so it'd be Adafruit/product 3500, and that shows you the actual trinket board that we're using. And then on this, there's a link for CircuitPython guides and capabilities. When you click that, you have this link which brings you to the actual different firmwares for the trinket. So when you go to get the firmware, you can get the latest firmware, you can get different versions of the firmware. So it has all of the resources there for you to download for that specific board. So if you're wanting to upgrade the firmware from the file I use, you can use that as a resource. And then all of the information about the badge is at 3kbadge.altbeer.us, and that is this webpage which goes into details about how we assembled the badge. It goes into the parts list in case you got just one of the PCBs and you wanted to buy the parts to make it into a working badge. There's step-by-step assembly guide here. And the code is detailed out on how I did what I did and why I did what I did. But this whole thing is run on GitHub, so when you click the GitHub link, it brings you to the GitHub section where the code actually lives. And you'll see in GitHub here, there's the firmware that I use for the trinket, and then here's my code for the trinket. So you can feel free to write your own code, or you can use mine as a starting base. This is the code that was preloaded to the badges that I built and sold at DEF CON. And with that, that is the end of the 3000 Society DEF CON Godzilla vs. Blade Runner badge build. I hope you enjoyed this video, and thank you for watching.